Hello everyone, welcome to today's math class. Check out this math problem before us here. The question is 4 to the power of sine squared theta plus 4 to the power of cos squared theta equal to 5. What is the value of cosec theta? How do we solve this? Alright, so let's take our solution and see how we can solve this. So we have a solution. Wow. First thing we're going to do here is to rewrite either this sine squared theta and cos squared theta. In other words, the two of them to have the same exponent at the top here. So we must have a sound knowledge of some trig identity. We know from trig identity that our sine, let's take sine theta, or sorry, sine squared theta, right, plus our cos squared theta is equal to 1. Now, because we are asked to find cosec squared theta, then we want to make cos squared theta the subject of the formula. So we're going to have here cos squared theta is equal to 1 minus our sine squared theta. So look at here. From here, we have that this is this. And here, this is equivalent to this. So we can rewrite the whole equation to give us here our 4 sine to the power of sine squared theta, then plus our 4 into 1 minus sine squared theta, everything equal to 5. Okay. According to the law of indices, it says that if you have your a to the power of your m minus your n, yeah, this is same thing as your a to the power of m times your a to the power of minus n. Remember this? And this we can equally express as our a to the power of m, then all over our a to the power of n. So we're going to make use of this law here. So rewrite this our expression here. Okay, so the first case is going to give us 4 to the power of sine squared theta, then plus our 4 to the power of 1, then times 4 to the power of minus sine squared theta equal to 5. So we want to eliminate this minus, so we have here 4 to the power of sine squared theta, then plus r4 all over 4 to the power of sine squared theta. Everything equal to 5. All right. Now, with what we have here now, you discover that we are having 4 to the power of sine squared theta. Here we're also having 4 to the power of sine squared theta. So we can do a simple substitution here. So we can here now say, let 4 to the power of sine squared theta, yeah, be equal to, let's take it to be y. Okay, so if it is y, what does that imply? Then we can rewrite this equation here now. So let's come in here where we have some space and rewrite that expression. So from here, it now implies here we're going to have our, or this now implies that our y, yeah, right, there plus our 4 all over y equal to r5. Easy. So we can eliminate this denominator here by multiplying both sides of the equation by 5. No, that was, sorry, by y. So this is going to give us y times y plus our 4 all over y times y equal to 5 times y. So here we're going to have y to the power of 2. This will leave, so we now have plus 4 is equal to 5y. Easy, right? Good. So we want to move this to this side of the equation to give us y to the power of 2 minus 5y plus r4 equal to 0. This is a quadratic equation. So what do? We solve this quadratically. Let's see if we can use the factorization method. And we get two numbers from the factors of 4 that when we multiply together will give us positive 4. Their summation will give us minus 5. Yes, that will give us minus 1 and minus 4. Yeah. So this is going to give us y to the power of 2 minus y, then minus 4y plus our 4 equal to 0. So we put this in bracket, put this in bracket. We factor out terms that are common here and terms that are common here. So here we have y common here. Y into y square will give us just y minus y into y will give us 1. Then minus what is common here and here is just 4. So we have here 4 bracket 4 into y, 4y rather will give us y, minus times plus will give us minus, then 4 into 4 will give us 1, everything equal to 0. Here we discover that here we have y minus 1, and here we also have y minus 1. So we're going to take one of them, and then we take this outside them there. So we're going to have this to be y minus 1 plus bracket, bracket, y minus 4, everything equal to 0. So from here, we apply what we call the zero product rule, where we send this to 0, equate this to 0 also. So let's take our first case here. So we have case 1. Our case 1, we have y minus 1 equal to 0. Then we take this other side as our case 2. We have our case 2. As our case 2, we have here y minus 4 equal to 0. So what we do, we send this to this side, send this to this side. So if you move this to this, we're going to have here y is equals to positive 1, and here we have y is equals to positive 4. So let's quickly give this y2 and this y1. All right, so now let's consider these two cases here now. Remember, we are asked to solve for cosec theta. So for us to solve for cosec theta, remember we don't have y in the system. So the only thing that will enable us to solve for that is to come back to where we said let 4 to the power of sine squared theta be y. So from here, let's continue on this side and see what this gives us. So from here, we're going to say recall. So recall that we said, we said 4 to the power of sine squared theta be equal to y. So from our first case scenario, we have here y is equal to 4. We have here 4 to the power of sine squared theta, right? Then equal to 1. Now, if we put in here 4 as a base number, to what power can we raise it to? To give us 1 is 0. So this can also be written as 4 to the power of 0. So the bases are the same. So we can equate the exponents. So we now have here sine squared theta is equal to 0. Take the square root of both sides. So we're going to have here sine theta is equal to 0. So let's keep this first expression first. Let's keep it, right? So we now take our case 2. Here we're going to have our 4 to the power of sine squared theta, right? Equal to, here we have 4. And this 4 is same thing as 4 to the power of 1. Then the bases are the same. Again, this will now give us sine squared theta is equals to 1. So if we take the square root of both sides, we're going to have our sine theta will now be equal to plus minus 1. Now we have another solution here now. Now we are not looking for the value of theta. Remember, look at what we are asked to look for. Cosec theta. Now, if you recall again from our trig identity, we know that your cosec theta is equal to 1 all over sine theta. Remember this? Good. So from here, we're going to take the third solution here now. So what is our sine theta here? Sine theta here is 0. From this place is 0, right? So if you have 1 all over 0, that will still give us 0. So from, let's take on this very one here, we're going to have here cosec theta is equal to 1 all over 0, which is equal to 0. So therefore, we now have here cosec theta is equal to 0. Let's keep this and solve for the other possible values of cosec theta from here. Now we have two values from here. We're going to do the same thing to this, right? So we take the first one. We have here our cosec theta is equal to, going to have 1 all over 1, which is equal to 1. So therefore, we now have here cosec theta is equal to 1. So we have a nice solution from here now. Okay, so this first solution and this another solution. Let's look for the other one, which is the last one. Yeah, we have it to be minus 1. So this is going to give us cosec theta is equals to, what do we have? We said 1 all over sine theta, right? And here we have, what is our sine theta? Sine theta is equivalent to minus 1. So we have here cosec theta is equals to 1 all over minus 1, which is automatically minus 1. So therefore, our cosec theta is equals to minus 1. Now, from here, you can actually get the value of theta. Okay, from these three case scenario, this very one, this one, and this one. You can get the actual value of theta, either from here or from this. Okay, but from the question, look at what we are asked to look for cosec theta. And these are the three possible values for our cosec theta. We have positive 1, we have negative 1, and we have 0. All right, so this brings us to the end of this math class. If you gain something from this video tutorial, give the video a thumbs up. Remember, this is Online Maths TV, and if you're not subscribed, subscribe. When you subscribe, turn on notification bell so that you get notified whenever we drop a wonderful video. Thanks for being there. See you in our next class. Keep winning. Bye for now.